Bravo from 207. Master arm on, master arm on. See, good light. Box one. Oh, Jesus. Good hit on one. Roger that. Good kill.
It just turned out that McLean wanted to demonstrate some techniques for guidance and needed a vehicle to do it with. Felt there was a need, but it was in many respects more an exploration of the techniques for guidance at the beginning rather than it was a conscious intent to design a anti-aircraft missile.
The technology base of the late 1940s didn't yet support effective air-to-air guided missiles. The weapons being tried tended toward complexity and notable unreliability. Aircraft rockets, descendants of those developed by the Caltech-Navy partnership that established China Lake during World War II, were seen by some as at least an interim solution to the air intercept problem. However, although rockets dramatically increased aircraft firepower, their accuracy against maneuvering targets continued to pose a problem. Once a rocket was launched, it would fly a ballistic course no matter what the target did. In 1949, at China Lake, a feasibility study was initiated of the development of what was to be called the heat-homing rocket. This rocket evolved into Sidewinder, the world's first infrared homing air-to-air guided missile. The first air-to-air missile to see extensive combat. The first to be designed with simplicity in mind.
Gas turbo generator we developed. It supplies all the electrical power for the seeker while the missile's flying toward the target. No batteries in this missile, no hydraulics either. Nothing to leak, nothing to charge, nothing to freeze. Just push the button and away she goes.
Accurate, reliable, producible, and amazingly economical. Sidewinder set the standard. And the Sidewinder has literally spread around the world. For every region, for nearly every nation, and for almost any conceivable mission, there has been some sort of Sidewinder. From the ubiquitous AIM-9Bs and their Soviet copies, to Subwinder and even Spacewinder, the China Lake Snake has had an unprecedented 5-decade run. And yet, this was a program the Navy had not asked for.
It really wasn't planned by anybody. It was not planned by the Navy. It had a missile and didn't see why it needed another one. The Air Force had plans to have a missile in Falcon, and it didn't see any reason to have one.
We were, pretty much competing with and then against Falcon, including the time we went down there later for the shoot-off when they never got in the air, much less fired a missile.
Although guided missiles were, at the time, specifically excluded from the station's charter, by the early 1950s it seemed just about everyone at China Lake was working on Sidewinder. Dr. L.T.E. Thompson, Knott's first technical director, and Admiral William S. Parsons, then Assistant Chief of BUORD, enthusiastically supported Sidewinder and transferred experimental funds to its early development.
There was some money pried out, of course, on the Sidewinder project every once in a while by gimmicks, call it installing a fuse today. Was a missile yesterday, tomorrow it's not a missile, it's a fuse, and this sort of thing.
Although Sidewinder enjoyed some powerful patronage in the Bureau of Ordnance, not everyone in the bureaucracy was pulling for the program.
K.T. Keller had been hired by President Truman to be his guided missile czar, and we did our best to convince Keller that we were a viable program, but he decided to kill us. So we went underground. We didn't stop. We worked harder than ever.
The man behind Sidewinder was Dr. William B. McLean, a mild-mannered physicist and one-time student of Dr. Lauritsen at Caltech. McLean's career at China Lake was nothing less than remarkable. In 1954, after only 9 years at the station, he would become technical director and serve in that position for 13 years, longer than anyone before or since.
The Caltech mafia that started the place, the Thompsons and the Lauritsens and the like, all respected Bill. And the initial Navy people, like Petey Stroop, all provided an umbrella of protection for Bill so that he could do things that subsequently, as the alumni became less powerful, subsequent TDs were not able to do because they didn't have the protection that the system provided Bill.
McLean was very shy. A lot of people, and me included, think that he was a technical genius. Well, he was. But more than that, he was an administrative genius.
Bill had an ability to understand what the state-of-the-art was able to do at any given period in time, and always was willing to adjust the performance to meet what was a doable do rather than putting objectives out which were beyond what the state-of-the-art could then accomplish.
McLean was interested in guided missiles long before he came to Inyukurn in 1945. At the Bureau of Standards, he worked on the Bat glide bomb, devising gyroscope systems for stabilizing the missile. As head of the fire control section at China Lake, he was acutely aware of the fundamental limitations of aircraft fire control systems.
The great difficulty, of course, with fire control systems is that the fire control system cannot take account of unpredicted maneuvers of the target after the bullets or the rockets have been launched. This caused Dr. McLean to feel that if he could put somehow the fire control system in the rocket, then the fire control system could continue to calculate the proper intercept point in space as the rocket proceeded on its way toward the target, and maneuvers of the target would be effectively compensated for right up to the point of intercept. Now, of course, fire control systems are rather complicated and they're rather expensive, and consequently a great premium was placed by Dr. McLean on keeping the fire control system in the rocket very simple and very inexpensive. After all, with each shot, you throw away one complete fire control system.
In fact, the Sidewinder was sort of an accident. After the war, World War II, Bureau of Aeronautics said, well, we're in charge of airplanes, therefore we're in charge of all missiles launched from airplanes. Well, we worked for Buord and we were going to do Sidewinder. And there was great animosity between Buord and Buer, because it was clear that Buer was making a real mess out of the Sparrow program, and the Sidewinder was moving right along, doing pretty well. And so I think Buord funded it just out of spite.
Sidewinder's early development and its early rocket moniker reflected some of the historical and philosophical differences between the Navy's Bureau of Ordnance and Bureau of Aeronautics.
Back in the old days, the Bureau of Ordnance had a whole establishment of draftsmen where they actually designed a lot of their stuff. Now we're not talking, we're talking about guns and gun turrets and things of this nature. So I think it was a natural progression for the Bureau of Ordnance organizations to pick this up and say, we'll do our work in-house.
In-house meant within the Naval Gun Factory, or later on within Navy laboratories such as Dahlgren, White Oak, and China Lake.
There were two growing corporate operations that were in the field of the Bureau of Aeronautics. One airframe manufacturer and the other airplane engines.
BuAer typically turned to contractors such as Curtiss, McDonnell, Grumman, or Douglas to develop aircraft for the fleet. With little or no commercial applications supporting ordnance development, Buord fostered and maintained in-house expertise.
3, 2, 1, 0.
The Buord philosophy also helped Sidewinder's designers look at the missile as a piece of ordnance, a complete round, simple and robust, reliable, maintainable, and producible, as well as effective and economical. Guided missiles were a BuAer mission, while to Buord went rockets. Consequently, China Lake would use its own in-house research funding to develop a heat-homing rocket, something within its official purview, at least in name. There could not have been a better venue for the development of a new guided missile. The Naval Ordnance Test Station, or NOTS, China Lake, combined research laboratories, complete shops, and highly instrumented ranges with fleet aircraft and crews. The station had the Navy's concentration of aircraft rocket expertise, along with its own pilot plants for propellants and explosives. And NOTS had been in the aircraft fire control business practically since its inception as a Bureau of Ordnance activity. Beginning in 1947, NOTS had used in-house funding to survey guided missile technology and had begun investigating infrared homing for air-to-air applications. An optical tracker was demonstrated the following year, along with a hot gas servo control valve, two innovations that would be key to Sidewinder. In November 1947, Bill McLean noted his original design for a target seeker, a seminal development in Sidewinder's evolution. Following an unsuccessful attempt to create a guided missile using off-the-shelf components, NOTS was officially withdrawn from guided missile work per se in 1948. However, by 1949, NOTS' heat-homing rocket was well enough along to request funding from the Bureau. Successful demonstrations of essential Sidewinder technologies followed in rapid succession. During 1950, NOTS demonstrated its Sunseeker prototype and the hot gas control servo. Buord authorized fuse development, followed by combined warhead and flight systems development for a heat-seeking missile. The putative missile incorporated numerous highly innovative and unconventional concepts. Canard control that required no autopilot, no reference gyros but a free gyro seeker platform, and no batteries. A pyrotechnic-driven alternator provided power. The optics were rotating, gimbal-mounted, and magnetically processed. Roll control was derived from air-driven gyro tabs, those mysterious rollerons. China Lake's heat-homing rocket rapidly became something far more than a conglomeration of advanced technology demonstrations. In November 1950, it was christened Sidewinder, in honor of another deadly heat seeker native to the Mojave Desert. The real turning point for the program came in late 1951, when Admiral Parsons, a longtime Knott's sponsor, came to China Lake for a presentation on the program. He became an enthusiastic supporter, and Sidewinder was established as an officially funded development program. The first aircraft launch came in the spring of 1952, and air firing of all up-guided rounds began in August. The principles of simplicity, reliability, and innovation, the things that would allow the missile to perform complex functions and remain simple in design, continued to drive the program. However, Sidewinder was not an overnight success, as legend would have it.
The first 12 missiles we fired didn't work. We didn't know why. We finally figured it out.
The 13th missile, fired on September 11th, 1953, missed the F-6 target by inches and was judged a successful intercept. 4 months later, Sidewinder hit the target.
It was January 9th, 1954, January the 9th. It was on a Saturday. I remember getting up that morning and my wife was in labor. And went on into work. They were talking about firing this missile. Sure enough, they got it off, and it hit.
When we hit that airplane, that was really remarkable because they succeeded in getting the airplane back. They landed it. And when I went out and looked at the airplane afterward, and I looked up inside, I put my head up inside the wing through the rent that had been made by the Sidewinders and went through. And here was, the main spar had been broken. But what was holding that wing on, I really don't know.
The Sidewinder team now knew that it had a missile, and Levy threw a small party.
Everybody was working hard and having a great time and laughing and scratching, but we had a cause. And the cause was, of course, Sidewinder. We all knew what we had here. And when I came here, I knew that my mandate was to get the missile out of the Mojave Desert and into the fleet.
The junk garage. Yeah. We never had a car in that garage. Double garage was always full of olive bills. That's junk, but that's where he did all his experiments. He used to go out there and work in that garage, come home from the office and have dinner, and then go out and work all day, all evening, then go work on Saturdays and Sundays. And of course, when we first went out there, all the fellows went back to work at night. They all did an awful lot of work at night.
Oh, I think everybody worked long hours, yeah. Howie's comment that you'd see the parking lot filled with Sidewinder cars, I think, is certainly true. All thought of work done at night. Just couldn't get it done.
To understand Sidewinder, you need to understand China Lake.
There's nowhere in industry you can do this, or in the Air Force or anywhere else. We could fire a missile and get the data, the telemetry, and a quick look at the camera film, go home and have supper, and come back and have a data analysis meeting that night. And then go over to the Chiefs Club, and Howie Wilcox would beat me at table tennis and beer drinking. But it was just fantastic.
A tight-knit community with a very active social life and a rich corporate culture. And a place where concepts often advance toward fruition, at the club or over the backyard fence. If China Lake looked a bit bleak to the early arrivals, they nonetheless found themselves in both a laboratory and a community in which they could thrive.
Bleak. I asked Howie when I got here, this is a pretty bleak place, isn't it? He said, yep, pretty bleak. But it gets green in the summer, but you won't see much of that. You'll be in the lab.
And I loved it. Because you learn very quickly that if you have water, good shoes, and a hat, there's nothing the desert can do to hurt you. And mostly it was the work situation. It was just fantastically good.
The work and the work environment were fantastically good. And in this strange place, military and civilian families lived and worked side by side, a continent away from their Washington overlords. An exciting professional life and a very active social life came together to create a unique community.
Yeah, it was a tremendously active social life. We were on a military reservation. We were 150 miles away from the nearest big town. There was a lot of socializing that went on, and a very fun kind of socializing it was. Yeah, very much so.
I would say in recollection, the most fantastic education I had was getting to know civilians again. I was a Navy lieutenant when I came back there. And at that point in life, civilians were aliens to us. We never even lived near them. We didn't visit them. Now we're next door to them. We do parties together. We have beer parties, bring your own booze, that kind of thing. And they became like other military friends. We're very close to us.
The corporate culture that evolved from the forced integration of isolated academics with combat-seasoned operators nurtured creativity, initiative, and a drive to serve the fleet. And it fostered popular legends of Bill McLean's garage and the wonders that poured forth therefrom, of secret projects and stolen funds, and of maverick missileers who battled bureaucracy and bucked the system. The Christmas parties of the old Aviation Ordnance Department, where lie many of Sidewinder's deepest roots, became the stuff of legend. And the Sidewinder saga was celebrated in song and story and stick-figure epic.
By the old Sierra Mountains, looking eastward in their lee, lies a laboratory building off limits by decree. And the range that's in the desert, for which my heart does yearn. Come ye back, ye civil servants, come ye back to Inyokern, on the road to Inyokern, where the missiles twist and turn. Can't you hear the sand a-blowing from Ridgecrest to Inyokern?
Over the years, I spent all of my sea duty in the carrier business somewhere, and all of my shore duty in the R&D business somewhere, but none of the other R&D assignments were anything like the laboratory assignment here at China Lake. Now, the Sidewinder is an interesting example of a product being developed that some of the user community said they don't need until they see how it works, and I said, "Gee, I'd like quite a few more of those."
The missile worked 6 months before the simulation ever worked. So the very early part, it wasn't so much in the simulation as it was in the examining of the partial differential equations associated with proportional navigation homing. You could anticipate things, and you could measure some of them with telemetry before they got to the point that simulation could do it adequately. The simulation improved, and the use of hardware in the loop in simulation came into play. Tom Amley was a great one on simulation, and he was very pleased that he was able to demonstrate in simulation some of the things that were causing a competitive missile, namely the Falcon, to miss regularly.
Although Sidewinder would help establish China Lake as a pioneer in the application of computer simulation to weapons development, full-scale flight testing was accelerated to an amazing pitch. "51 guided flights were made at China Lake during 1954 alone, and nearly 90 shots were made of various versions over the next year. An essential aspect of the program was the presence of fleet aviators and their close relationship to the RDT&E team.
I was the project officer and the project pilot. The three men I mentioned earlier, essentially Bill McLean, Howie Wilcox, and Walt LaBerge, were the principals of the Sidewinder project. And I think I flew all but Bill McLean in the F-3D. We had a side-by-side jet. And they had never been in an airplane before, yet they're developing a weapon that supposedly, and has, of course, over 30 years, very nicely destroyed an aircraft target. But Howie and Walt LaBerge both flew with me in the F-3D, which I thought was a pretty dink jet compared to the combat stuff I used to fly. It was one of the few jets where you were shown in the handbook as wearing a baseball cap, and it had a cigarette lighter and everything in the cockpit, so it's kind of a casual airplane. But they enjoyed it.
1955 saw numerous milestones on the way to the fleet. The first firing at a Dart tow target. The first firing at a jet aircraft target. And the first firing from an aircraft flying at over Mach 1. "88 missiles were air-launched during the year, which culminated in Sidewinder's release to operational evaluation in January 1956. Sidewinder 1 entered the fleet in June 1956 as the AIM-9A. In less than 2 years, Sidewinder would earn its place in history. In the fall of 1958, over the Straits of Formosa, F-86s of the Republic of China were defending the island of Taiwan against Red Chinese MiGs. On the 24th of September, 18 Chinese Sabres, 4 of them carrying Sidewinder, encountered a large force of Chi-Com MiGs.
That day, we don't check in. So the airplane actually towed over to the runway end. We started engine, took off. But in the air, for some reason, I don't have a radio. I cannot hear anything, and I try to click the mic, and no response. But my commander have confidence in me. We just approaching it from behind, bring up the nose, and my leader shoot one, I shoot one. One explosion after another. There's maybe a second apart. That's the first time it happens we shoot Sidewinder.
In its first combat outing, Sidewinder scored 4 MiG-17 kills. The enemy scattered in the face of the first sortie of the guided missile era.
I felt that this is the ideal application of the Sidewinder missile to suppress what promised to become a shooting war, because it made it clear to the other side that, hey, they were not going to be able to dominate the air. Or in fact, they were not even going to be able to compete in the air.
After that, not too long, political reasons. So our Air Force never go cross over the middle line, and their Air Force also don't cross the middle line, so not much contact anymore, no more.
Sidewinder had been established as a player on the world stage.
They were absolutely convinced there was no way we were going to hit it. And so the first flight they set up was one against a high noon firing against the white sands. And they can't, other than looking at the sun, there's probably not a hotter IR background to fire an infrared-seeking missile into.
We were in the final stages of buttoning it up, getting it ready for the fleet. I mentioned to Bill McLean, I said, you know, really the Air Force needs this missile a lot more than the Navy does. You know, the country would be better off if this were an Air Force missile than if it were a Navy missile. I says to Bill, I said, we ought to sell the missile to the Air Force. He said, well, why don't we?
After being assured by the Air Force that it had no need for Sidewinder, Wilcox enlisted Charlie Lauritsen's help in convincing irascible Air Force missile maven and one-time Lauritsen student Trevor Gardner. But the sale would hinge on a shoot-off against the Air Force contender, the Falcon. The shoot-off held at Holloman Air Force Base in June 1955 is a popular page in the Sidewinder story, and illustrative of the real and perceived differences between competing missile programs and competing military services. Even before the target drones were launched, the comparison was dramatic. Falcon's cartloads of complex test equipment and a dozen or so trained technicians against Sidewinder's Ordy chief with little more than a Simpson meter and a flashlight.
We had a little console about yay big to do a final check on the guidance unit to at least see that it was turning up and would track and such. We did all of our tests back here. Then we hauled the guidance unit there. I don't think we had much with us other than maybe a flashlight or something like that for a target. It was just interesting to see the difference in the large complex and such that I remember there being there for Falcon at Holloman. And that was not where they did the developing. That was just where they did the final checkouts before they took them out and fired. And we had a bench in the corner of the hangar, and all of our work was done in a small lab that was a fraction of the size of theirs out there. So we took a little pride in that.
The Falcon was supposed to shoot first. And there were two targets. There was a Sidewinder target drone and there was a Falcon target drone. But the Falcon couldn't seem to get off the airplane. They never could get the missile to go. So they gave the shot to Sidewinder.
Following a string of no-fires of the complex and temperamental Falcon, a warheadless telemetered Sidewinder took the first drone's tail right off, destroying it and annoying the Air Force hosts.
He fired, and the missile, it was fairly short-range shot, maybe 5,000, 10,000 feet. It was still new, the aerial warfare. And the missile went on down there and literally knocked the tail off this QF-80. Took the whole tail off.
And so we went up and we shot down the target, first shot.
Several more Falcon no tests were followed with another one-shot kill by the Sidewinder. The Navy had made its point, but it still took a half-dozen high-altitude shots against Knots-built target rockets to convince the Air Force to buy into the program. Well before Sidewinder's 1958 combat debut, and even before its first test range intercept, program plans had begun to diverge. While the China Lake team was pushing to get the basic Sidewinder 1 capability, the AIM-9A, into the fleet, the station was already developing the advanced technologies for new generations of the missile. The flexibility of the system was also evident early on, and by the early 50s, China Lake designers were already pointing Sidewinders in unexpected directions.
They'd go up and down the valley trying to see if the Sidewinder would react against a railroad locomotive. These were diesels or steam, and at night it was really neat. It would light up like mad. So you could actually visualize it as an air-to-ground weapon in those days.
The Knotts team was also taking steps to ensure the future of the weapon by establishing the engineering disciplines, the documentation control, and the relationship with production contractors that would become hallmarks of Sidewinder and set the pattern for success for many other programs.
The early Sidewinder 1As had an extremely good documentation package. That documentation package was actually drawn over in Mike's lab. And that documentation package then were given to the contractor, and he built to that package.
During 1955, a second source production contract was let for Sidewinder guidance and control. The ensuing competition between Philco and GE for the lion's share of production signaled the beginning of one of the cornerstones of Sidewinder's success and of the so-called China Lake Way. Competitive production under strict Navy laboratory control improved product quality and dramatically lowered cost. Above and aside development and testing of the missile itself, China Lake's integrated military-civilian team pursued nearly every aspect of the total weapon system, from how it was packaged and how it fit aboard ship, to manuals, fleet introduction, and training. Knotts designed missile system test and checkout equipment, and even handling gear. China Lake designed its own specialized instrumentation and test support equipment, and developed test and training targets ranging from converted fighters and bombers to air and surface-launched target rockets. Knotts designed telemetry systems, on the ground and in the missile, went to the range and to the fleet. And, in great secrecy, China Lake developed countermeasures for its own weapons. Not only did this support the development of countermeasures, it helped keep us at least a couple steps ahead of an adversary notoriously adept at imitation. By the spring of 1956, with Sidewinder 1 in the fleet, Knotts was concentrating on getting the improvements of the 1A incorporated. The AIM-9A was a basic capability missile that gave the fleet an immediate advantage in the air. The Navy had gone ahead and fielded the 9A to get that advantage, even though better capabilities were literally only months away from fruition. The 9A had limited range and high-altitude performance. It didn't even need roller-ons. But the 1As were in the wings, as it were. These new missiles would become the ubiquitous AIM-9Bs, with better range and performance, and the trademark roller-ons restored. By the fall of 1958, the Air Force had adopted Sidewinder, and the fleet was well into the replacement of its 9As with the AIM-9B. U.S. allies were demanding basic Sidewinder capability. And at home, the Sidewinder team was firing developmental versions of the next-generation missiles. More powerful motors, deadlier warheads, novel fusing concepts. The cutting edge of materials and fabrication technology applied to airframes and electronics, to sensors and domes and detectors. Sidewinder was evolving daily in the lab and on the range. Small teams of experts in every conceivable area of guided missiledom often competed with one another for the next upgrade or the next version to go to the fleet. While refining and improving the Sidewinder 1A, China Lake was also pursuing Sidewinder 1B, a low-drag, folding-fin, higher-performance missile that would allow internal carriage. The 1C, an improved 1A, was progressing rapidly, as was the 1R, also known as Raywinder, with its passive radar seeker. These were leading-edge, high-tech efforts in the 1950s. And these were efforts given high priority by the Navy.
The high-speed, high-altitude fighter aircraft of the post-1960 era will impose serious limitations on the Sidewinder 1A infrared homing missile. However, by exploiting the proven design of the Sidewinder 1A missile system, we can meet the more exacting air-to-air combat conditions.
The 1A was the Sidewinder that went to the fleet. The 1B was the first move toward an ogive nose. It was a small diameter seeker, and that went no place in the Sidewinder program, but it did get used in the Red-Eye program on the first of the shoulder-fired heat-seeking missiles. The 1C was actually a program that consisted of 3 different heads. The IRA was the infrared alternate head, SARA was the semi-active radar alternate head, and the dual mode was a combination of infrared and semi-active radar. This designation, 1A, B, and C, has caused no end of difficulty because we then moved into the AIM-9 series, and you got AIM-9A, AIM-9B, AIM-9C, AIM-9D, etc.
While the designators may have been confusing, the China Lake team was quite clear in its purposes. And this competing project approach was an important element in the success of Sidewinder, and of the station as a whole.
You just had competing individuals here on the base. And one thing that Dr. McLean always pushed for was competition. He did not like monopolies. Compete on designs and thoughts so that you would encourage innovation. And I think that in almost no other organization would you have been able to do this to keep the competing systems going.
SARA and IRA went to the fleet in 1964 as the second-generation Sidewinders AIM-9C and AIM-9D. As the AIM-9D, IRA would be the key element in the U.S. fighter arsenal in an air war that was rapidly heating up. By 1967, Sidewinder had proved itself the most effective air-to-air weapon in use in Southeast Asia, scoring the majority of Navy and Air Force combat kills.
And I got my speed up, and I said, well, if he's going to run, I'm not going to. So at that point, I turned the airplane, got a tone, fired, and the missile went right up his tailpipe, and he blew up. And that was 3 Sidewinders, 3 kills that day, and it worked out fine. The reason that I had used Sidewinders is that the AIM-7 Sparrow only had a 7% kill ratio earlier in the war.
1967 also saw the Winder become a deciding factor in the air war in the Middle East, with the Israeli Air Force scoring multiple victories against Soviet-equipped adversaries. And the German Sidewinder, designated the Mod 14K, went into production. For the hot war and for the cold, Sidewinder's evolution continued at a manic pace during the 1960s. The radar Sidewinder had been given high priority by the Navy in the late 50s. With the advent of the AIM-9C and D, the priority became the development of a solid-state version. The AIM-9H would leave behind the size and complexity of the vacuum tubes of earlier models and allow for expanded capabilities in the same proven airframe. By 1969, the upgraded 9D, the AIM-9G, had brought off-boresight launch capability to our fighters. and the Army had joined the Sidewinder Club with the deployment of Chaparral. Intensified air activity in Southeast Asia in 1972 and 73 demonstrated the effectiveness of Top Gun training and the top performance of the AIM-9D and G Sidewinders. The 73 war in the Middle East, too, saw Sidewinder scoring the majority of Israeli air-to-air kills. And by the end of the decade, the third generation of winders, the AIM-9L, was in the fleet. Its successor was already under development at China Lake.
The original Sidewinders, the old Sidewinder Bs that came out, had very little track capability to it. And long before I was ever in Vietnam, they were already started working on the AIM-9s to improve them. We also put in and said we need a missile that will do even more than that, which came out to be the AIM-9 Lima, which you could shoot at higher angles, even head-on. We needed more sensitivity to the seeker so that you could shoot an airplane looking at the intake instead of the tailpipe, which they came about. A lot of us wrote about those things in different documents, and when I was at Top Gun, we studied and wrote, recommendations to Washington, D.C., and a lot of those things they heard.
Now, all of these things were developed and evolved from really the Sidewinder Seeker.
We worked on several different concepts.
Well, build a radar Sidewinder, basically.
No, Hamburg, it was going to be a ground-launched version of Sidewinder.
Originally a super idea, just ground-launched the Sidewinder.
Sarah was badly needed because...
What it was a simple modification. We took old AIM-9B hardware.
Focus 1, Focus 2, and Focus 3, which were versions of Sidewinder.
And they'd modify them into an anti-radiation missile.
We were always trying to find some mod we could put on a AIM-9B and make it into another weapon.
We did even try to fire it from 60 feet below the water in the Subwinder program.
The immediacy of combat requirements during the conflict in Southeast Asia bred a veritable legion of Sidewinder knockoffs and odd applications. This wasn't new, nor did it end with the war in Vietnam. China Lake had been planning and actually making converter-winders since before the missile officially deployed. Everything from T&E targets to several secret super Sidewinders flowed from the China Lake laboratory over the years.
This was so classified at that time that it didn't have a name in reality. It was hidden under HAP, and even HAP wasn't really an official name. Initially, they said they didn't want a name for classification reasons, but you had to refer to it as something. A high-altitude project. It was the most anonymous thing they could find. It was basically classed for talking purposes as a high-altitude probe with no military significance.
Some chapters in the Sidewinder story are virtually unknown, even to the China Lakers who helped write them.
And Russians had done. The Russians had furnished Foxbats and pilots to the Egyptians, and they started to fly over Sinai. And they would come mid-Mach 3 something, Mach 4 something, faster than we had ever seen anything move at that time.
Sidewinder seekers had already been adapted for other missiles, for bombs, and for range instrumentation. Higher and faster was an obvious progression.
What it was ultimately is we took a Sparrow rocket motor and we would mate a Sidewinder front end and guidance set to it and put wings on it. And the people in the simulation lab said, you could catch one of these fox bats doing a tail shot with a Sparrow rocket motor boosting the Sidewinder front end up and let it guide. These were pre-production 9L heads.
HAP was not the only super Sidewinder, nor was it the first. It was not even the only mating of a Sidewinder seeker with a larger motor.
The HAP, which was done on sort of a dare, was a super Sidewinder. But way before that, we started with a Diamondback, which was going to be a bigger and super Sidewinder that would carry a nuclear warhead, but also had a conventional warhead being designed for it.
Also long hidden behind walls of classification, the original Super Sidewinder was begun even before the original Sidewinder went to the fleet. In 1955, Knots began the development of Diamondback, a long-range missile envisioned for the early 60s and based on the advanced IR Sidewinder then under development. Diamondback used a larger airframe and had a liquid-fueled demand-thrust motor. Like most of its contemporaries, it also had an option for a nuclear warhead. Although the active development program was ended late in 1958, advanced guidance work went into the AIM-9G Sidewinder, and the rocket motor technology provided the basis for Knott's experimental lunar lander. A contemporary of HAP was the Super Sidewinder of the 70s, Agile. Like Diamondback, Agile was referred to by many as a Super AIM-9, but Agile, the ex-AIM-95, was in many ways the opposite of Diamondback. Elegant, small, and extremely technological. Two versions were pursued, an Aero Agile, centering on an advanced Sidewinder airframe, and a thrust vector control Agile, drawing on technology developed by China Lake under Project QuickTurn. Agile investigated multiple mode seekers and incorporated a helmet-coupled sight concept. The system and technologies were demonstrated during the early and mid-1970s. Following the program's demise, its technologies benefited a number of other cutting-edge China Lake programs.
Well, right before we passed, not more than, I don't know, 1,000 feet in front of us, a missile comes off the lead fitter's airplane, and it goes right by us, passes maybe a couple hundred feet. And I remember looking down at that and thinking, golly, I can't believe he just shot at us. Because we knew what they carried, and they were carrying ATOLs.
Shoot him! I got a tone. Got the second one. I got the second one on the nose right now. Hey, I'm high cover on you. Lock him up. Lock him up. Man, shoot him, Fox 2. So what?
And I see the smoke trail of the Sidewinder. We're at about half a mile, 45 degrees off his tail. The missile had obviously pulled some lead and then just broke sharply and hit the tail of his aircraft at a pretty high track crossing angle. It was not a real big explosion, but pieces of his tail came off.
Good kill. Hey, good kill. Pilot ejected.
Larry and his jet chasing the lead are just a couple miles north of us right now, and he fires right up the tailpipe of the lead aircraft with no maneuvers. Big black fireball there.
The early 80s saw a new spate of Sidewinder successes as Snakes defended the fleet over the Gulf of Sidra. The Israelis took out 51 Syrian MiGs over the Bekaa Valley. And British Sea Harriers shot down 17 aggressors over the Falklands.
The numbers of Sidewinders that we've built and employed and used around the world, and not just our
service, but in our allies' forces has been quite dramatic.
As the 80s waned, the end of the Cold War may have been in sight in retrospect, but it was far from the end of the Sidewinder. By the middle of the 1980s, the drive for internal carriage for the sake of aerodynamics had been replaced with a concern for stealth. And the legacy of the proposed folding wing 1B, which had briefly returned as Foldwinder in the late 1950s, rose again at China Lake in the BOA. BOA, a compressed airframe, advanced capability Sidewinder derivative, first flew in 1990. Several variants were tested during the ensuing decade, demonstrating impressive capabilities beyond those of supposedly more advanced systems. A fourth-generation Sidewinder, the AIM-9R, with a radically different guidance concept using an imaging seeker, was demonstrated by China Lake, along with advanced technologies for sensor and dome materials and for countermeasures.
2, 1, 0.
The fleet Sidewinder of the day, the AIM-9M, remained in the forefront. And during Operation Desert Storm in 1991, U.S. and Allied pilots downed Iraqi MiGs, Sukhois, and Mirages, shooting from Tomcats, Eagles, and Hornets.
It was a daytime strike. The time on target was about 1400. So the sun was high. We were basically, when we were approaching about 30 miles south of the target, when we had the merge with the MiG-21s, we actually were in a wall. It was an unintentional formation. We were planning on being kind of in an offset battle box, but as it turns out, we were as offensive as we could have been against a formation like that. The bandits are being referenced against Manny, so you'd hear these calls, bandits, Manny, 18525 southbound.
Bandit Manny 18525 southbound.
Bandits Manny 18525 southbound. The E2 guy, a guy named John Joyce, came up and made a dynamite call, and he goes, 400, that bandit's on your nose at 15.
400, that bandit's on your nose at 15.
So I immediately went to a quick lock Sidewinder, 20-mile, and immediately got a lock on a supersonic Iraqi MiG-21 at, he's about Mach 1.3, coming straight at me at about 9 miles. At the exact same time that I see the guy, I get a tone, there's a shoot light, so I take the shot. There's a flash, a big puff of black smoke, and then an airplane. He's on fire. There's no question that the Sidewinder did the job.
The 9M remains the fleet's high card for the dogfight. But there is a new generation on the horizon. A new development by Raytheon based on Sidewinder, the AIM-9X. Drawing upon technologies previously developed and demonstrated in Sidewinder, Agile, AIM-9R, and other programs, AIM-9X incorporates advanced steering methodologies and an imaging seeker, along with a helmet-mounted sight. Sidewinder's legacy was and is profound. Knotts developed the principle of a simple, reliable, accurate, and producible missile with its own fire control system, and made that missile adaptable to a wide variety of aircraft. So successful was the missile, and so potent and adaptable its technology, that Sidewinder came to be seen in some quarters as the answer to any and every fleet need. Surface-launched Sidewinders went from Hamburger, the ground round, to Osprey, and finally to Chaparral, which was launched from trailers, treads, and even armored decks. Sidewinder-derived concepts covered the complete range, from Subwinder to Spacewinder, and the combinations pitched, tried, and fielded over the years were legion. Bombwinder, Bullwinder, and Sparrowwinder, and even a few other winders hidden under names like Focus, and Hap, and Bullwinkle, and Side Pump, and Sidearm. There was a Foldwinder to be carried internally, and a Raywinder with radar guidance, and even laser-guided and dual-mode winders. Sidewinder has literally spread around the world. It's been produced and copied by friend and foe alike. An amazing success.
It's a simple missile to employ. It's straightforward in its design. Its complexity is certainly increased as it's evolved over the years, but it was designed to be an easy missile to shoot, a reliable missile to get a good kill, and one that you didn't have to think a lot about or really work hard to sweeten up your shot. All of those increasing complexities brought a combat capability that was still the world beater, and that still enabled pilots to feel comfortable with this missile. They knew that it was going to work, and it has proven that, I think. And its reliability steadily improved over the decades. And I'm thrilled to have been associated with it, and very much appreciate the heritage that China Lake has brought to the American fighter pilot through the Sidewinder.
With its phenomenal success in the fleet and its worldwide reputation, Sidewinder rapidly became the China Lake icon, a symbol of how things could be done and how things should be done. Sidewinder embodied the principles of the China Lake Way, full-spectrum RDT&E in an atmosphere that fostered creativity and initiative. Although Sidewinder is far from the station's only product, it rapidly became the most visible one. Sidewinder's success was shared by every member of the China Lake military civilian industry team, from the scientists who pioneered its technologies and the engineers who designed its hardware, to the technicians who assembled it, the machinists who built the parts, the ordnance techs who loaded its motors and warheads, the ordies who loaded it on the planes, the aviators who flew it, the tech writers who wrote the reports and manuals, the draftsmen who drew the schematics, the photographers and range techs who supported the tests, the tradesmen who kept the labs and ranges running, the administrators who kept the money flowing, and the secretaries who actually ran the whole place.
I agree with those who say it's a magnificent thing that it has succeeded to survive through so many generations of engineers.